Hello everyone, it is time for Customizing Normals Video 2. We're going to be talking about normal transfer using the data transfer modifier. It has a bunch of options and we're going to get familiar with how it works on a low level and how it can actually be used to solve the various issues we identified in the first video, which you should watch if you have not. There are other videos out there that cover various normal transfer setups. But here we're going to be taking a general approach to understanding how it all works. We already know that we'll be getting into more powerful transfer setups using geometry nodes in the end, but that doesn't mean a lot cannot be done with the regular modifier. And explaining how it works first will help us build up to all the things we'll need to know for the later geonode and shader node setups. In this video, we'll mostly be looking at typical basic setups and identifying their problems. Then in the next video, we'll look at more complex setups that give better results and are easier to work with. And then in later videos, we'll switch over to geometry nodes and increase the setup complexity even more, but in return, it's even better and more convenient to use, once built. Also a note for the many people who have been asking me about using these methods in game engines. A lot of these things won't work directly there because game engines don't support things like normal transfer for performance reasons. But everything we're going to learn could be saved to vertex normals or better beta tangent normal maps in the end. So even if we can't address every issue that we can in Blender, we can at least have nice normals and a decent artistic experience making them. But I am talking with some people who are trying to get some equivalent things working in game engines. And if they come up with anything, I'll certainly mention it. And as we go through this series, I will be taking note of what will and won't work in game engines as we get further in. So before we start looking at our modifiers, let's look at our basic interface setup I've done here. I've added a couple extra properties windows. This one is for the key light here. You can select the key light and you pin it with the pin, and then no matter what else you select, it stays up here, so we can easily access the rotation. I've also opened one for simplify so we can get to our subsurf level for everything at once from the same spot. And hiding on my other monitor is our material. I've got a couple of groups of things we might want to look at on the model frequently. So I've got a group of shaders, which looks like that. If you want to pause and create it yourself, it's kind of a mess, and also one for different normals. So we've got absolute and XYZ and different axes combinations, so I don't have to keep setting these up with split XYZ. Most of the time I'm going to have it on this one. The XYZ absolute lets us see sort of the contours of our normal channel, because generally speaking, if these lines are wiggly, then the shading is not going to be too great. And for the shader, it's just a greater than 0, so it's just lit or unlit, which is the simplest toon shader you can have. And it's also the least forgiving, so this is the worst things can possibly look. And I've multiplied that over by 0.9, so it doesn't go full black in the shadows, so we can still see a bit of our normals. Okay, so a very basic normal transfer setup that you've probably seen if you've watched other videos about this. I'm starting with a sphere. I made a lattice, and I've already got a shape key on this, and this has wrapped the sphere around the head, about matching its size and proportions. And then actually I applied that, I made another copy because I weight painted this already, but I guess you could have done that without applying the lattice. For the data transfer modifier, we're targeting the sphere mesh. It's on the default replace and the not default projected face interpolated. And let's turn that on. And that's doing mostly the right thing. That's got some jackiness still, but if we give it a level of subsurf, it cleans up pretty nicely. We'll leave the subsurf off as much as possible for performance. So here's an option you should know about. If I move this around, nothing is happening. But if I toggle this on the modifier, now when I move it, it's unhappy. So what this toggle is doing is telling it if it should count object movement into the comparison between the two, or if it should ignore it. So when it's like this, it's basically anything I do on this object is just ignored. So that's handy to have if you want to stick your transfer mesh side by side if you're, rendering and comparing, and you don't want it to get in the way. But we don't really need it right now. Let's take a look at what we've got in detail. I'm going to hide the sphere so it doesn't block things. And as we move the light, we can see that things are actually pretty clean, but there's a few oddities. Like the nose there, what is that? And on the eyes, why is this still catching the light? And what's going on in here? I mean, it's inside the eye socket, so it doesn't really matter. We'll probably mask it out. And there's also some weirdness on the ears. You can see it clearly on this one here. That doesn't look like a sphere there. But we can also see that some things are very nice and clean. Like, these triangles here aren't causing interpolation problems that we can cleanly see if we turn this off, like that. Or if we turn up the subsurf level, it gets even worse. So we're getting some mixed results. It's solving some problems, but it still has some issues. The nose problem is pretty straightforward. If I turn the mesh back on, we can see that the nose is actually going outside the transfer mesh. And I've already got a shape key built on here, and if we turn that on, it pulls the front out a bit, and the problem goes away. So the cause for this problem is the mapping type we're using. This behavior actually makes sense if we understand what projected face interpolated mapping does. From the tooltip, we can see that it is a copy from interpolated corners of the source polygon hit by quarter normal projection. Wonderful. But luckily, I do know what that means. So if we go into edit mode and we enable face normal display, first note that it's messed up on one side. I'm pretty sure this is a bug with the mirror modifier. If we look at other normal types, it doesn't do that, and these normals are behaving correctly. So ignore that. So for a given face, well, actually for its face corner, but we'll get to that later, just pretend for now it's just the face. If we follow the normal direction until it hits the source mesh, which is hard to see for this one, it would be like over here somewhere, then this face is going to get the normals at that point on the source mesh. And those are also interpolated, so it's the interpolation of the vertex normals that we talked about in the previous intro video. So if you don't remember how that works, go and check that part 2 of the overview video again. So the reason it's getting it wrong when the nose is sticking out is because when you draw a line from this face, it doesn't hit anything in the positive normal direction. It hits it in the negative normal direction only, because it checks the front and the back of the face. If we move this around again, what we can see here is the problem we're having is that on these areas that are outside the mesh, the normal is actually inverted. And that's because it's the back-facing detecting it. It's only really showing up in a few places. Technically, it's happening here, but it's hard to tell. So if you're going to use projected face interpolated, then you have to make sure you keep everything inside the source mesh. So now that we know that, we can also understand the other problems we're having, like what's going on in the eye sockets. Well, these faces are pointing that way. So the value these faces are getting from the source mesh is something from way up here. So that's why they're shading, like the faces way up here. That's what's actually going on. And these faces here are pointing this way a bit, so they're shading like over here on the front. And there's not really anything we can do about that. That's the downside of projected face interpolated, is you just don't have great control if your mesh has a lot of faces pointing in different directions. The other issue to note with it, if we turn our shape key back on to fix our nose, is there's just a lot of space between the source and destination meshes, and that just generally makes this all imprecise. Projected face interpolated is great if you're just doing a rough shape like this sphere, but if you were trying to do detail with it, then things quickly start to cause problems. So, should we use a different type of mapping? Let's look at what else we have to work with here. So we're not going to touch topology yet, because that's for transferring between two identical meshes. Let's try nearest corner of nearest face. And it's terrible. And so is the other versions of nearest corner. And that's because none of these are interpolated. If we go to projected face interpolated and we put this on shade flat, it's similar. So basically, we can only use the interpolated ones and have it work out. So let's try nearest face interpolated. And That's certainly better than the others, but it's still not as nice and clean as projected. But it is clearing up the eye issue. And that's because this isn't based on the normals of the destination object at all. It's just for a given face, it's finding the nearest face on the source mesh and getting its normal. And actually, part of the reason this looks as bad as it does is that shape key we've got, since we're adding so much extra distance between the face and the transfer cage. So when we turn that off, things do improve. Now, they're still not great. They're not really improved at this angle, although they're still okay here. Because what we're seeing here is that the interpolation issues are pretty bad. If we do some subsurf, that's going to help quite a bit. But we can still see the edges of the faces created by subsurf. This is, even with all this subsurf, it's still basically worse than our projected. The projected is just so clean in comparison. Okay, so there's minor differences between both our major options. They both have minor problems. Let's see how they compare when we use the face rig. So I've rigged the sphere to the jaw, and it's going to move with that. And that's behaving just fine, actually. It's a little bit weird on the inside of the mouth there because we're on projected, and so that's, pointing off here somewhere. But this is still fulfilling the major goal. I left the nose off, but whatever. And if we switch to nearest face interpolated, that's actually doing an even better job of, straightening things up. But it's still really unhappy when it goes diagonally across those uneven faces. So both of these are behaving just fine on large deforms like opening the mouth. And we, make some real nightmare stuff if we want. But that's accomplishing our general goal of surviving deforms. So how about for rig detail? I've got a ton of small controllers on this face because if you recall from the previous video, I have all of these bendy bone strands. And if I move them around, nothing's happening because, well, I haven't even rigged the sphere to these bones because how would you? It just doesn't have enough points. This sphere transfer is good for obliterating detail, but it's not really ever going to cleanly pick up detail. And that's not really its fault. It's just not really cut out for the job. This issue is going to exist for basically any method you use to override most of the details of the face. We want to establish one big clean shape, and then we're just going to have to add back the detail by a different method. So the fact that this behaves this way isn't really a point against anything here. And we can see that with either mapping method, it's going to behave about the same, because it's just going to ignore the motion and project the shape over the mesh as it lines up. So this isn't really a problem specific to any sort of data transfer. So we'll move on from the rig issues for now and take a closer look at these other mappings. If we understand our mapping options better, we might be able to find some solutions to the problems we had. So here's a plane. I'm going to put the display on just XYZ, so just the normals. So this is black because we're looking at -1y. And then on this pyramid, we can see some stuff, and then the black parts are -z and -x. We are on projected face interpolated, and when we enable it, we can see that faces that the pyramid is over get some data transferred. And if we scale the pyramid up, it's going to cover more, and we can move it out a bit. And this is a bit weird to look at because these black areas are just getting negative numbers. If I put this back to showing absolute, then we can see more of it. It's just now, it's symmetrical, so it's a bit more confusing. And of course, it doesn't matter which one of these we move. And we can also, rotate it. So that's projected. Let's look at a different one. Like this one that wasn't working before, nearest corner of nearest face. And that's weird. What are we? Oh, geez. That's psychedelic. Let's go back to the non-absolute normal display. Does this make any more sense? And if we will make this even more confusing, shade smooth. now it's getting a bit easier to see what's happening. On this quarter of the pyramid, this is all a negative, and all of this stuff is matching that, all of this stuff is matching that, etc. So it's the nearest corner of the nearest face. So for each face in the destination mesh, so for this face, it finds the nearest corner of the nearest face of this mesh, which is blue. And so everything up here is going to have that as the nearest corner, so they all get that. And that's true of all of these nearest corner ones. There is some other stuff going on, like it's checking the normals in some of these, but that doesn't make any difference on a flat plane, and it won't really help us. So basically, nearest corner and all of these are useful for some types of data transfer, or some things you might want to do, but they'll basically never be useful for transferring smooth normals. So we can just pretend these three don't exist. We'll go back to the flat shading, and let's look at our nearest face interpolated now, which is giving us pretty much the same thing at the moment, because we can't really see the interpolation in this example. So, yeah, the main difference is these nearest base ones versus the projected. Projected is happy to find nothing and just return, well, it doesn't change anything. We're just looking at the same normal we started with on this face if it doesn't find a face to transfer from. Whereas everything else is going to transfer from some face, and you're not going to have your original normal left anymore. So this is actually a new method we can use. Because projection only goes onto the corresponding faces, we can use this to project details from like a detail source mesh onto a destination mesh. Of course, how well that works is going to depend on the amount of vertices we have to receive it. Like, let's give this some subsurf, and now it's able to pick up more. And it's jagged because this is flat shaded, but if we shade smooth, it's actually getting quite a bit of that pyramid shape now. Let's turn on the shader. Look at just the shader. I'll move this out a bunch. And if we move our light source around, there's our pyramid on our flat mesh. I mean, there's not a whole lot to see from it here, but it is there. So how far can we really take this method? Let's make our shape a bit more complicated. I've got some simple deforms wrapping it into a half sphere, and we need to move the subdivision up, because right now, well, we use a smooth one, it's fine, or we can use simple and put it first. It doesn't really matter. You don't want the smooth before, because otherwise it rounds off your edges. That's fine. And now we can see that this does still work. Let's move it a bit closer. It is kind of finicky because we have to match the angle. But conceivably, we could use a method like this to add details, maybe a nose or something like that. Although the limiting factor is basically the number of vertices there are to receive it. Remember, we've actually got all of those. If we go up higher in resolution, then we have even more, and it can pick things up better. But it's never going to look that good with this many points. We need so many vertices to make this look correct. But actually, there is a way to get that many, which is to make this to a texture, because then the limiting factor is the pixels, not the vertices. So what we would do is we would crank the subsurf up to like 7 or 8, which would be hard to handle in the viewport on a complex model, but you can handle it in an F12 render. So we turn it up really high, and then we bake that to a normal map, and as long as we have enough vertices, and then it will work out fine. Or we could even blur it after to clean things up. So we don't actually have to let this limited vertex problem hold us back overall, but we're not going to talk about texture baking until much later in this video series. For another example, let's lay our plane flat again, and instead of this, I've got a half sphere. Let's set that as the target for the data transfer. And I'm going to set it to wireframe only. So it's not too great on the edges, but it's actually pretty good in the interior. So keep that in mind, because we can also mask those edges out to some extent. And again, we'll just go up way higher in the subsurf count. And if we look at the normals themselves, there is our sphere. And of course, it's banded because of the shader. Yeah, there's the actual normals. So we can see that other than the border, those are actually quite clean. It's because of the interpolation between the vertices. So the other way this could be used when baking is you fill basically the whole thing. And if there isn't a hard border like that, then you don't really have a problem. That border is there because it's projected. Or if we go back to a nearest face interpolated, we can get something similar, although now we actually have issues, and that's because given the size of this whole thing, the nearest face isn't necessarily going to give us the clean curvature. And if you remember, we were basically seeing this issue on our actual head before, which is part of why the nearest face interpolated is never quite as clean on the edges as the projection is. So both projected and nearest face interpolated have their own problems, and in both cases, those problems come from the troublesome issues with comparing two shapes in 3D space. Like, we could get rid of this if it was doing the nearest face only on the y-axis. And then it would be a lot more like projection. But that would only work in this case where this plane is flat. If it was on the actual head mesh, then nearest on y wouldn't necessarily work. We kind of need nearest on normals, but then we'd have the problem projection has where if something like the inside of the eye socket is sticking that way, then it's going to pick up something over here. So we kind of want a mix of both of these, but without their problems, or we want some way to get rid of these issues caused by projecting and nearest and the realities of being 3D meshes. And of course, that's where we're going to get to our final mapping type, which is topology. Topology mapping transfers information between identical meshes. So here we've got a copy of the mesh, and I've got some shape keys on it. And as we turn these on, we can see that the changes they make on this mesh are affecting the normals of this one. And that also goes for really crazy changes. Like here is a cast modifier that's wrapping this into a sphere. It looks ridiculous, but that's actually giving us some pretty nice and clean sphere normals. So we can do all sorts of things to our mesh to get the right normals as long as it stays identical. But what exactly is defining identical? Obviously, it's not the shape if we can do all that. So is it the vertices? Let's add some knifed-in vertices, and that breaks it. We can see an error message now. Let's undo that, and how about adding some new edges between existing vertices? That also breaks it. We can actually get away with some pretty radical changes as long as they're the right type. So I'm going to select all of my seams and hit V to split edges. And now the face has been split up into all these different sections. And as I move these around, it's not breaking. And we can see if I rotate them, it is still transferring the normals properly. So how come we can do this, but not all the other stuff? It has to do with the type of data we're transferring. I'm actually going to undo all that because we don't actually want this split. But if we go into edit mode, we can enable indices if we have developer options enabled in settings. And then if we select vertex, we can see the index. Every vertex in the mesh is numbered 0 through, the highest number. And if we select both, we can see that these have identical indices in the same place. If we go into edge select mode, then we're looking at the edge indices, or in face mode, it's the face indices. So all a topology transfer is doing is for whatever index, for whatever data type on this mesh, it's going to transfer that data to the corresponding index on the other mesh. So when the mesh is a copy, they're always going to line up. But as soon as you remove anything, like if we delete this face, this is 1392, then as soon as this is deleted, it recalculates the indices because you can't have a missing spot. So whatever face was 1393, which who knows where that is, it's up here. If we delete 1392, this has become 1392. It's moved everything by one index, everything that was higher, in order to close the gap. So that breaks our transfer. So the data transfer modifier checks to make sure you have the same number of the relevant element on both meshes. So as long as you have the same number of faces, you can do a face transfer, even if you have a different number of vertices. But it doesn't always detect that the mesh is actually different, because you can have a situation where your meshes will have the same number of elements, but in a different order. Let's make an example. Here is two planes, and on one of them, we are going to subdivide it so that we have a total of 4 vertex loops in each direction. And we can see our indices. It's going 0, 1, 2, 3, because that's the vertices of the original square before we subdivided it. Now on this copy, instead, we are going to loop cut it that way and then that way. And if we look at both, the index order is different. This has 6, this is 8, because it was increasing the indices as the vertices were created. So if we do a data transfer and aim it at this and put it on vertex data, there's no error message. So if, say, we had a vertex group on both, that one's empty. On this one, we'll put these vertices into the group, and we'll turn on vertex group weights. And then on this one, we're going to set it to transfer vertex groups by topology. And we'll just do group. Now, if we apply that, the order is completely different. So it properly transferred to the corresponding index, it's just not giving us the right thing. So this isn't a problem you'll normally have when just working with a duplicate of your original mesh, but where it can start to come up is if you're using modifiers to change things, to adjust your shape, or when we get to using geometry nodes, because in geometry nodes, there is no error check. So it will let you transfer things with different numbers of vertices, and it will transfer the vertices, the indices it can, and then do various weird things with the ones it can't. But let's go back to why we were able to transfer still from the split-up version of the mesh, which I'm not going to recreate, and that's because we are using face data, well, face corner data. So even though we had changed the number of vertices and edges by splitting some of the edges, we hadn't changed the number of faces, so the indices still lined up. So we can split things, but there are still ramifications for doing that. So I've added some modifiers here. Here's an edge split that's splitting all edges, and a smooth so we can see it. And now we have flat shading. And of course we have that because we're transferring vertex normals, and we know a vertex normal is the average of the connected faces. So if there's no connected face, then it's just going to be the same as the face, and that's flat shading. But hold on, wait, I just said vertex normals, but it's face corner data. So let's talk about what a face corner actually is. So if you're storing data on a face level, then the whole face has the same value. But what happens if you need different values in different areas? Well, then you could store it on the vertex level. But then you have one vertex for all of these, so this vertex will have the same value, and if you're doing interpolation, that will influence all of the faces around it. What happens if you want to have a different value in this corner than in this corner? You need the ability to have different values on different faces connected to the same vertex for normals, vertex colors, and UVs. And vertex colors and UVs are probably the place we're most used to seeing this. So we can go into vertex colors and select just one vertex, grab blue, and we paint on the vertex. We're seeing it interpolating it the same value for all of the connected faces. But we can also go into face select mode, and now when we paint it, it paints on just one corner of the face without going onto the other faces. And of course, we see this all the time with UVs. Here's the UV map for this face, and it's split into multiple pieces. The mesh isn't, but it actually kind of is behind the scenes for this. The reason you can have this split in the UV editor is because you have face corners. And we can select just one island and move that, and now that's split off too. So we have the same phenomenon of splitting edges, it's just only on the UV version. But for the behind-the-scenes data, that's not really different. When dealing with normals, you need this ability for split edges, like from AutoSmooth, also known as sharp. We mark sharp, and now it's no longer interpolating over that edge. And of course, we can also get split edges from changing the auto-smooth threshold. We go lower, this is automatically splitting the edges at lower and lower angles, until we get 0 and we have all the edges split and we're back to flat shading. But if we go into edit mode and look at the mesh, they're not actually split. And we can also view these split normals, which is also known as custom normals, which is what we are transferring with data transfer over here. So we've got our face normals, we've got our vertex normals, and we have our split normals. So we can see here that there's multiple normal lines per vertex. There's one for each face, because that's the normal saved for each of those face corners. On a data level, the way that these face corners work is that for a given face, if we go back to our indices, instead of remembering, say, this vertex by index, it remembers what's its first index around the face. That's the association. And we can actually go take a look at these in Blender's data API if we want. We'll add a new outliner and set it to data API. We can go in and find our objects, and then we're on head topo. Here's all the objects in the file, so it's a bit of a mess. And that one. And in here is all of the stuff, all of the settings on this object. And if we go into the data, it's all of the settings for the data. And in here, we have all of our vertices by index. So we can see what its index is, where it is, the vertex normal. And we've got that for vertices and edges and polygons as faces. I don't actually know why it has polygon normal and polygon listed twice, because polygon also goes through to polygon normal. There's a bunch of stuff I don't really understand about the structure. The actual face normal is here under polygon, but that is just the flat shaded face normal. The custom normals are actually under loops. And this is a bit hard to read because the loop is the vertices around the face, often called a face loop, not to be confused with selecting a loop of faces. But the way they're recorded in the API is kind of confusing because it has one entry for each vertex in the loop or something like that. And if we go and look at the normal for it, none of these actually show anything. And that's because it's not calculated yet. Because the custom normal is a calculation of the base normal plus whatever offset we've gotten from splitting edges or data transfer or normal editing. And it's not storing that constantly in the API. It's storing that offset value somewhere in the file, but it's not viewable here. So in order to actually get the custom split normals that we look at, you have to calculate it. So the interface is doing that live. If we're looking at it here, when we're looking at these things, it's run a command to calculate these, and it's basically redoing that all the time. But the calculated custom normal isn't what's actually stored here. So just because there doesn't seem to be any data here doesn't mean it's not somewhere. It's just not really organized in a human-readable way. So basically, that's all just a bunch of trivia that maybe you were curious about. It doesn't really influence how we work with these things. The important thing to understand is that edges, vertices, and faces are kind of the fundamental elements of a mesh, and then face corners are kind of a higher level thing built on top of those. It's based on information from both vertices and faces in order to let us achieve what we need to have different values on faces that share the same vertex. And that will come up more when we get to geometry nodes. The thing that is important to know for what we're actually trying to do with data transfer is that you can have your source mesh be split up into different pieces just like a UV map, which we're actually going to do in a little bit. But we have some simpler things to look at still first. Let's get back to our topology mapping. So it's always going to be an accurate transfer. We don't have to worry about where this mesh is or even what shape it's really in. So we can just try to get the shape we want by changing this, and that can be sculpting it with shape keys or modifiers or whatever you want to do. Let's look at some of our options. The cast modifier is really interesting because it casts whatever mesh you input into a predetermined shape, a sphere, a cylinder, or a cube. and you can control how much and adjust some of these parameters, and of course mask it to only certain areas. And then like, wow, if we go negative, that gets really weird. Real big brain stuff here. But that's nice if you want to get any mesh to the same shape. And the results this is giving us is actually pretty much the same as when we are transferring the normals from a sphere to the head. Although we can still see some minor issues. Let's try putting some Subsurf on. This is Subsurf after the cast modifier. As we turn that on, we can see that our uneven topology issues start creeping back in. If we put the Subsurf modifier before cast, then we don't have those problems. And that's because, of course, when it's after the cast, it's going to do the smoothing. The smoothing is based on the topology, so it's going to make it uneven again. So this is as clean as our projection. That's very nice. And it doesn't have to be a full sphere. We could say disable the z-axis, and now it looks even weirder. But this is actually a pretty good shape for a lot of our head. Like the cheeks are working quite well until we get to about the mouth. And then we can kind of see that the problem is there. So cast does a lot of what we want, and it's very clean. It's just going to be difficult to get quite the right shape. You know, we could try 0.8 maybe. That's looking pretty good. But now it hasn't fully smoothed out all of the details. You know, as soon as we're not the full sphere, then details start to creep back in, and it's generally going to be the details we don't want. Even at like 0.95, that's pretty good, but at this point, we might as well just be all the way to 1, right? So instead, how about we do the cuboid? Oh, we're not doing the cuboid. Cylinder. All right. That's messy on the neck, but we could mask that out of the data transfer. That's pretty clean. It's not really giving us the shape we want around the mouth, but in order to get that, we could introduce a lattice, which I already have set up. The lattice has a shape key on it in case I need to restore the base shape. And we can pop into edit mode on this lattice. Make sure I grab the bottom. I've got proportional editing on, and now we can make some changes. And disable Subsurf to make it a bit cleaner. Let's try sharp. And we get to watch in real time what this is doing on our mesh. So we'll do that a bit. How about a bit at the top here? I want to make sure I get all the way through. So now we're actually getting a pretty good shape. Let's get our Subsurf back. And the lattice is also after the Subsurf, so no interpolation problem is getting back in. This has given us, that's a lot of what we want. Again, it's really nice and clean. It's better than our proximity transfer methods. It's not too great under the chin because we're not really getting the chin, but we could probably, we'll mask the data transfer with a vertex group, you know, at the chin line, and then it doesn't matter how bad it is on the neck and stuff. If we wanted to get under the chin working, we could use a separate mesh and transfer from that, or, you know, whatever. There's lots of ways we can handle masking things in different areas, or use multiple data transfer modifiers for different shapes. So yeah, that's pretty good. Now, how does it hold up when we use the rig? So first of all, even though the transfer doesn't care that this object is offset here, the rig does. Like, if we turn these nightmarish modifiers off for a minute, we can see the rig is not behaving properly on the copy of the head because it's all the way over there. So we're going to need to set this one back to the original location, and same thing with its lattice. And then we can re-enable this stuff and hide it. And we'll just see what's happening with the normals. Move the jaw a bit. And that looks like it's behaving pretty well. We have what we had before where it's kind of, the shading is moving over it. It's not really moving with it. And if we hide this head instead, we can see what's happening is, since our armature is before the cast, it's kind of going to keep casting it into the same sort of shape, regardless of the deforms. So basically, that means it's not picking up the deforms properly, which isn't necessarily bad. Maybe you want this effect that no matter what you do with the jaw or, bigger deforms. I'm only using the jaw here just for simplicity's sake, but if your face was squashing and stretching or something, you'd have the same problem. So maybe you want this and maybe you don't. And if this is what you want, then this is actually a great method to use. We can still see that we have some topology and interpolation issues here, but those go away really fast with a couple levels of Subsurf. It's bad at the top and it's weird at the bottom because, of course, our cast object is super weird there. But if you just need like a clean cheek shadow without too much other bells and whistles, if you're not really worried about details, then this method, mask out the top and bottom back to your original mesh or back to a different transfer type, and you're pretty much good to go. Now, the reason that this cast method works is because even though the topology has issues, it's being projected into a very clean shape. So everything is where you need it to be to avoid those interpolation issues. And this isn't the only way to do that. The other notable way is if you use a shrink map modifier. You model the shape you want, like a cylinder or whatever, and then you shrink wrap the face onto that. And it has various options to do that. So you can get a similar effect with more control like that. I'm not going to show that setup just because it would be a bunch to show and you can get the point from this. Now, none of these projection-based methods are going to really support fine details. Like, we can't really cast the nose into a proper nose shape as part of the same mesh. But that's true of a lot of these methods. Generally speaking, we're going to use one method to establish the overall shape of the face, and then use other methods to add details. So to sum up topology mapping, it's easy to duplicate your mesh and change it into whatever shape you want. And how well that works is really just dependent on what your topology is. If you already have very clean topology, unlike me, then that's a very easy method. And if your topology has bad bits, like my various triangles, then the only way you're going to get it clean is to cast it or project it into a clean shape. And we need to watch out for using any modifiers like Subsurf that makes those interpolation issues worse. Another one is the smooth modifier. So it may be tempting to just smooth your mesh into something cleaner. You think, I'll throw enough smooth at it and it'll be clean, right? And that's mostly true. But as you can see here, first of all, we have unintended consequences with details like the mouth, but that could be masked out with the Vertex group. But second is, it's still not really addressing these areas as nicely as we'd like. It's not necessarily awful, but it's just difficult to control. So if you go high enough, the things are so smooth that it kind of works, but this isn't actually giving us something we want here. It is pretty clean, but it's just not really what we want. Of course, if you subsurf before the smooth, then it has more points to work with, and it doesn't change the shape as much. And if we subsurf after the smooth, then we're going to be reintroducing topology issues again. So smooth can play a role, but it's not as easy as just throwing a ton of smooth at it. So that covers how topology mapping goes for creating a clean stylized shape in the first place. But that's not the only thing it's good for. There's another one of our major problems it can help us with. So we have various problems caused by deformations. On the base face, it's bring all this shading in as the mouth opens because there's a lot of complex stuff going on around the mouth. And if we use normal transfer from proximity, then that's going to solve the problem by basically hiding everything. But even then, it can have kind of unintended consequences. And, that kind of depends on what projection method you're using. In this case, the inside of the lips is pointing that way, so it's going to be unreliable. And on nearest face interpolated, it's okay, but then we have the downsides of using that. But mostly the problem is that we lose all detail now. And if we're doing one of the topology transfer methods we looked at, then we could have a similar problem of wiping out all our detail if we're using like a projecting into a shape, or we could just have, whatever other problem is associated with our topology mesh, or if we're just using a mesh where we're not doing some crazy modifier and we're just smoothing it or something, then generally it's not going to address these issues at all because you're going to have similar deforms from the rig on whatever that mesh is. But there is another option. Here is a topology copy, and I'm now using geometry nodes to offset these so that they're in the same place when the rig is applied, but then the mesh gets moved so we can see what's going on. So this one has had its rigging changed. So we're sticking to our pattern of our normal source mesh looking absolutely freaky and weird, but that's just how it goes. Go ahead and enable that transfer, and we can see that it is an improvement. Now, it's not much of an improvement, and this isn't a great example because these are still messy base normals. But the point I'm trying to show you here is that with this method, it's just stretching what's there instead of introducing any new changes. And that's because this has been rigged to not introduce any new changes. I've reduced the rigging to just the jawbone and the head bone and removed all the other little bones this has. So it's a big improvement over introducing a whole new shading shape. If we spent a bunch of time using the methods we've been talking about to clean up this face shading, then we'd be preserving good shading instead of bad shading. But I just wanted to demonstrate the principle. I'm not going to do all the weight painting because I'm too lazy. And we have methods I prefer for dealing with these issues coming up ahead in later videos. But it's good to know about this option. All right, at this point, we have looked at all the options and run through a lot of examples, and we have a pretty good idea of how this is all going to shake out. Basically, our proximity mappings are good at some things, and our topology mappings are good at others, and for the most part, the things that proximity mappings are good at is the things topology mappings are bad at, and vice versa. So if there's a way we can get the best of both worlds, then we can solve pretty much all these problems. This is exactly what we'll be doing in the next video. We can chain multiple data transfers together so that we can get the best out of both mappings while avoiding their issues. This lets us solve most of the problems we've identified and makes for setups that, while more complicated, are actually easier to work with. Thanks for watching. Please like and subscribe, and if you've got any questions about this or anything related, feel free to leave a comment, or you can find my contact information on the YouTube About page if you want to email or DM me. I'm also on Twitter, which is where I'm most active, posting updates and work in progress and all that. And if you really like what you're seeing, then I have a Patreon, and every little bit helps. Thanks, and I'll see you next video.